Generally, the winding in the armature, the moving part that in which the voltage is induced, there are two different types of windings. One is called lap winding and one is called wave winding. What is the difference between the two and where they are used? So lap winding, as you can see in this figure, the way they do the lap winding is this is the commutator, different segments of the commutator, and as we discussed, you can have many segments of the commutator and many coils to make the output DC voltage as smooth as possible. So if one of your conductor is starting under the north magnetic pole on the commutator segment 1 and it is ending under the south pole on the other side under the other commutator segment number 2, then the next coil is going to start at the commutator segment 2 and the beginning of that coil will also be under the same pole where the beginning of the first coil was, and likewise the end of the coil is going to be the end of the coil is going to be on the third commutator segment under the south pole. So the beginning of the coil is going to be under the same pole but connected with different commutator segment, and end of the coil is going to be under the south pole or the other pole connected to different commutator segment. It is not very easy to understand from the figure, believe me. It's a little harder. It is quite easy to understand if you look at some of the videos on YouTube, like this mobile tutor videos, armature windings, lap and wave winding. Check that video out. It is very it explains it really good, and I think you will find it very beneficial. So I'm just gonna go over it real quick. So lap winding is considered as parallel winding. So the way they wind it, it creates parallel parallel electrical connections. And there are two types of lap winding, simplex winding and duplex winding. And you can read it, what is simplex winding, what is duplex winding, but in general, it is considered as parallel winding. That means it can carry high current. In parallel, you can carry more current because all the parallel paths, the current will be added together, but the voltage is going to be fixed, right? So wherever the requirement is high current, fixed voltage, you can use lap winding. Now in our book, in our study, the winding that we will be using for most of the problems is going to be lap winding. And this equation we will be using very frequently. So make sure you understand this equation. Perhaps you remember this equation. E0 is equal to Z and phi over 60. E0 is the induced voltage, total induced voltage in the winding. Z is the number of conductors, total conductors in the armature. And how do you calculate Z? Basically, Z is, you have total number of windings, and sometime it is given total number of slots. So total number of slots or total number of windings times how many turns you have how many turns you have per winding. So for example, if I have this winding and okay, very poor winding, but I have this winding and I can have multiple turns. I can go in and then I have multiple turns of this coil, right? So you have number of you have number of slots where you have coils, and then you have number of turns of each in each slot. So you multiply number of turn in each slots. So turns. Oops. Come on. And finally, when you have one turn, you have one conductor here where the voltage is going to be induced and the other conductor on the other side. So basically you have a winding like this. You're doing turn like this. So you have one conductor on top and one at the bottom. So you have two conductor per turn. So you have number of slots. Let's say I have 100 slots. So 100 slots I have 5 turns per coil, so I have 5 turns, and then 2 conductor per turn. So the total number of conductors that I will have will be 500 times 2, 1000 conductor in the armature. So again, this is how you calculate Z. So make sure you understand that. N is the speed of rotation of the armature in RPM, and phi is the flux per pole. So if you have multiple poles, many generators have multiple poles. If you have multiple poles, then flux per pole is phi. So if total flux is given to you and it is being told that there are 4 poles, you divide the total flux by 4, and that's going to be flux per pole. And 60 is there because you are calculating RPM and not in rotation per second, not in hertz, but in RPM. So 60 is there to convert minutes, basically to take care of the conversion between minutes and second. So the result, of course, E naught is voltage, so the units of E naught is going to be volt. So again, this formula is important, so remember that. The other type of winding is wave winding. Wave winding is called series winding. As you can see in this figure, one coil is starting at one section of commutator, and then it is ending at the other section of commutator under the other pole, and the next coil is starting where the first coil ended, and then it is going as it goes in series. So wave winding is a series winding. That means although it can carry less current, but you can have high voltage induced in the coils, because all the voltages connected in series, the winding connected series, all the voltages will be added together, and you can have high voltage, but it can carry less current. And again, there are 2 types of wave winding, progressive and retrogressive, and you can look at the differences and read the differences. In our study, we are not really using wave winding. Again, we are using lap winding for most of our problems, and we're going to be using the formula E naught Z and phi over 60 to calculate the induced voltage based on the calculation of conductors, speed of rotation of the coil of the armature, and flux per pole. And this picture shows you in a little bit of more detail. This is a lap wound generator, and this is a wave wound armature, lap wound armature and wave wound armature. So you can look at the difference of the two. But again, the easy thing is going to be to go on YouTube, and there are many videos. This is just one of them, but there are many videos that you can look at them, and you can understand different types of winding and how do you wound armature of a generator. So check them out.